So for the past week in science, we have been looking at matter, and we have talked about how matter is anything that takes up space. And then we've been looking at the way that scientists classify matter. Scientists, real scientists, look at the properties of matter to decide how to categorize it or how to classify it. So we've talked about how scientists look at color, they look at shape, they look at how hard something is, they look at whether or not the material is magnetic. And then on Friday, what you read about was how scientists look at how electricity can pass through a material. So here I have this pencil. It's clearly matter. It takes up space. But can electricity pass through it? Probably not. Okay, so you guys, on Friday, you read about some things that electricity can pass through, such as copper. Copper is something that they use to make wire out of a lot because electricity can pass right through it, which is great when you want electricity passing through something. And then they coat the copper in rubber or plastic so that the electricity will not hurt anybody. So some materials electricity can pass through. Some materials electricity cannot pass through. And that's really great for us because we can use both of those together to have electrical currents, but also stay safe. So scientists look at that quite a bit when they find materials. They look at whether or not electricity can pass through it. Is it a conductor of electricity? Okay. The other thing that they look at is thermal conductivity. Can the material conduct thermal energy? So let's read about this. Thermal conductivity. Matter is made up of particles that are always vibrating. We've talked about that, and you saw it in the simulations that we did. Those little particles were vibrating. When it's a gas, they're kind of vibrating all over the place and spreading out. When it's a liquid, they're a little close together, but they're still moving. And when it's a solid, they're very close together, but they're vibrating just a tiny bit. But they're always vibrating. The energy of moving particles is called thermal energy. The ability to conduct thermal energy is a physical property that can be used to help identify materials. Just like hardness, just like color, just like magnetism, we can use the ability to conduct thermal energy to identify materials. Good conductors of thermal energy, or thermal conductors, allow thermal energy to flow easily through them as heat. Metals such as copper, aluminum, and iron are good thermal conductors. Interesting. Sounds like some of those are also good electrical conductors. Cloth, wood, and rubber objects do not conduct thermal energy well. These materials are thermal insulators. We can use these materials to protect us from hot objects, such as a pot on a stove. Glass, plastic, and leather are also good thermal insulators. So think about why does that matter? Okay, look at all these pictures. Would you want to make a pan out of something that was not a good thermal conductor? No. You want your pan to be a great thermal conductor so that the heat can pass through it and cook your food, right? Okay, you'd never want to make a pan out of something that wasn't going to be a thermal conductor. Now, look at this picture down here. See what this guy is using to hold the pan? Would you want your hot pads to be thermal conductors? No, because you do not want heat passing through those hot pads. Otherwise, your hands would burn. Now, if you've ever used one of those, you do know that some heat does pass through. And so it's not to say that those materials are not thermal conductors. They just don't do it as well or as quickly as something like the material that this pan is made from. Okay, so let's look at these two spoons. We've talked about spoons a little bit this week. We've talked about the hardness and the color and the shape and the magnetism of spoons. So we have a metal spoon and we have a plastic spoon. Which spoon do you think would be better at conducting thermal energy? Hopefully you said the metal spoon. That would be right. The metal spoon would definitely be the one that would be better at conducting the thermal energy. Heat can pass through that spoon a lot easier than the plastic spoon. Okay, so for today, you're going to be going to Schoology, and we've just done, we're in the Monday folder in science, and we've just done the thermal conductivity reading. If you'd like to reread it, you certainly can open that and read it again yourself. And your work for today is this thermal conductivity question. So we're going to open this. And you're going to answer this question. It says, Rachel performed an investigation to study the thermal conductivity of 4 different materials. She started with 4 identically shaped rods, each made of a different material. Then she placed one end of each rod into a pot of boiling water, which was 100 degrees Celsius. That's really hot. After 5 minutes, Rachel measured the temperatures of the ends of the rods that were sticking up out of the pot to see whether they got hotter. Her results are shown below. So let's think about this for just a minute. Rachel took these 4 rods made out of 4 different materials. We're not sure yet what they are. She put them into boiling water, and then she measured the temperature of the rods sticking out of the water. I hope she didn't grab them with her hand, because if one of them happens to be a good thermal conductor, it's going to burn her hand, right? So I doubt she used her hand, but somehow she measured the temperature of these rods, and she recorded her results in this chart. Okay, so material 1 was 41 degrees Celsius. Now remember, the water was 100 degrees. So is this anywhere near 100? Not really. Material 2 was 53 degrees. Again, not really close to 100. Material 3 was 98 degrees. Very, very close to 100. Material 4 was 59 degrees. Not very close to 100. So if you had to guess which one of those was the better conductor of thermal energy, which one was heat able to pass through the easiest, that's what you should be thinking about. Okay, so when you click on the question, you should be thinking about this chart. All right? You should be thinking about which material did heat pass through the quickest and the easiest, because that material would be the one that was the best conductor of thermal energy. Good luck!